Agenda for tonight, I'll do a quick intro. How many people here first time Mobile Monday? Awesome. And so we'll talk about Mobile Monday, kind of what we're, the topic for tonight. And I'll introduce MobiledgeX as our keynote. These does a couple slides that cover like Edge Cloud. How many people here are really interested in Edge Cloud computing? Okay. How many people here in voice AI? Interested in voice AI? Interesting. How many people here have heard of 5G? The president talks about it, right? Okay, well, let's get started. So we're a developer and startup community, about 60,000 folks across 7 different cities across the U.S. I'm Mario Tapia, and I've been doing this for, in June it was 20 years. So it's been a long time. So I've done hundreds of these in a lot of tech cities across the world. Demographically, like, well, who typically comes on Monday? About 30 of you guys write code. Who writes code? Any people writing code here? People in product and marketing. Business development, sales. What about entrepreneurs, founders? Awesome. Any designers? It's like, I designed a chatbot, right? So where to find us? Well, how many people found us on Meetup? We also have a YouTube channel, so we record all our sessions, we post them on YouTube, MobileMonday SV. Same thing, follow us on MobileMonday SV on Facebook, and also on Twitter. And for those of you guys that tweet, pull out your camera, you guys want to take a picture, and please say thanks to Cloudflare and MobiledgeX for being our support and sponsorship tonight. And give a round of applause, please. So, a little bit about tonight. Future voice response. And so there's three growing technologies that are going to impact our ecosystem today. We have the emergence of 5G and the rollout of those new networks. So you guys seen a lot of posting, Verizon, some other folks posting their speeds. And it's like 2 gigabits, 3 gigabits, amazing. We're also talking about Edge Cloud. What's that? What does that mean? How's that different from cloud? How does that mean today? We're also going to talk about AI platforms and really like, well, how does 5G and Edge Cloud really going to impact AI platforms? How many people have played with or tested and assisted for another, whether it's Siri, Cortana, Alexa? People have played with it. How many people use it on a daily basis? Amazing. Okay, at least once a month, right? So we're also we have a representation about the developer ecosystem, so folks that are building on these platforms and building products for their business. So a little bit about who is in the room. So we did a survey when you guys registered, and we found that we have a good group of developers, product and marketing, development sales, a couple of venture folks, maybe one blogger, a couple UI folks, and then many of you are either CXO or co-founder, which is pretty cool. Definitely the startup ecosystem is alive and healthy. We also asked, like, okay, what verticals are you in? Some of the most popular ones, you guys are in the app ecosystem. Some of them I didn't really have a designation for you, but definitely you guys are also in finance. So a good healthy distribution across the board of verticals. So why this topic for tonight? From 2018 to 2019, we had almost a 40% growth in assistants in the house, which is a pretty substantial growth rate. And Gartner's forecasting by 2022, 2025, 75% of households will have a voice assistant or other. And how that's going to happen? That's going to be, well, your phones, your TVs, your microwave, your dishwasher. Just imagine how integrated these products are, or these services are going to be with your daily life. And this is kind of a quick look at ecosystem from the different players, really who, obviously Amazon with Echo kind of came out very strong in the ecosystem, but other players followed suit very quickly, and so we'll see basically kind of is that split race for penetration. Other slide shows like, well, is the time you're spending on your smartphone being now cannibalized by smart speakers? And the survey says yes. Those that use it at home, do you guys use it for playing music? How many people use it for playing music? Yeah, it's just easy, right? Hey, it's like it's easy to pull out your phone, right? It used to be, right? You pull out and play a song. I just kind of say, hey, Alexa, play X. Now a bunch of people at their home playing some song X. And the same thing, it's also kind of substituting what TV does. And I think a lot of the reasons is because it's very natural, right? So it's natural for speaking to some type of assistant, do this action for me, or fetch this information, just like we would do with the search engine. So that kind of gives you an idea of the scope of what we're talking about for tonight. Also kind of how it impacts you in your life. And next I'd like to bring up one of the part. Let's give a round of applause for Tina. Okay.
One part from MobiledgeX, I'm a director of product management. I've been with the company for about 15 months or so. I was the first product manager at MobiledgeX. Just a brief introduction of what MobiledgeX is. We're based in San Francisco, California. The company was founded in 2018, January, as a spin-off from Deutsche Telekom, and to accomplish the following mission, basically. So MobiledgeX is creating a marketplace of edge resources and services that connect developers to the world's largest operators to power next generation of applications or devices. So what we're trying to do is so our customers are developers, and we want developers to get to have a chance to run their application inside mobile operator network. So this is the current state of the network. There are about 3.7 billion devices out there, and there's for about over the last 10 years, about $300 billion spent on public cloud. But what people don't realize is that $1.7 trillion has been invested in network within the operator, serving as a network pipe. So yesterday, in the past, we had applications that run based on PC, right? It was primarily static applications. These days, a lot of applications run on mobile devices, and these are mostly content, Netflix, YouTube, things like that. But what's happening in the future is the next generation or next class of application, and we call it a PI application, where P stands for pervasive and immersive. These are AR applications, VR applications, or even drones, autonomous vehicles, things like that, where it requires a lot of video processing. It's very interactive, and it's very latency sensitive with high I/O. At the same time, a lot of privacy that needs to be secure, protecting a user data. So over the 2 years or so at MobiledgeX, I had an opportunity to work with many type of application developers, and most of the use cases of edge computing falls into 6 categories. Right, one is mobile data tuning. Instead of getting all that data into the cloud, how about to process it onto an edge before sending it over to a cloud? So we call that a mobile data tuning application. Next application is an IoT security application, where a lot of surveillance camera, things like that require processing on the edge. Right. Mobile gaming applications like AR multiplayer gaming, which requires very closed loop system instead of a lot of AR multiplayer gaming these days are mostly peer-to-peer, but how about putting all that into an edge, making it a hub and spoke model, which allows more devices to play at the same time. Because there is a law, it's an end problem instead of end square. As I mentioned, there's a VR, AR application that a lot of people use edge computing for compute offload use case. Drone swarming use case where we have a group of drones that want to work together, so it's a hyper-local type of use case. And finally, a compliance and privacy issue. As we work with operators are known to be trusted by users. They work very hard so that the data resides in that operator network. So any use cases that focuses or that emphasizes on privacy or data governance can be another use case. So for a smart speaker type of use case, I consider a mobile data pinning could be another one, or a compliance and privacy could be another type of application use case that application people can use for edge computing. So we talked about there's about 3 billions of devices out there. Cloud, we spent about $300 billion in CapEx and probably about $1.7 trillion on operator network. So the question for operator is, should the network provide more than just connectivity? And yes, it should, because by bringing, so previously, most of the application that runs on public cloud, even though there's a lot of regions out there, is still a static application. But if edge computing or if edge resources are widely available across different operators or widely, it's a truly distributed architecture where we can, instead of more of a static application deployment, it's more of an on-demand application. So based on the user requirements, we can actually bring that application closer to the user. And that's what we're trying to do. So a little bit of a technical solution that I'll briefly go over with. So this is the software architecture of MobiledgeX. There are different services that we are working on, but for ease of explanation, I'll just split this into half, where I'll talk about the Cloudlet Resource Manager first. So to us, Cloudlet is a pool of compute resources provided by operator at a particular location. That's our definition of Cloudlet. The Cloudlet Resource Manager is a piece of software that runs on each operator network, and the primary goal of Cloudlet Resource Manager is to bring up operator infrastructure. As we have found over the last year or so that each operator works with different vendors or SI, system integrators, that they have different IS steps. So what Cloudlet Resource Manager does is a lot of abstraction for our software to work across different IS steps. Another job of Cloudlet Resource Manager is to deploy developer application onto a particular cloud, right? Whether it's a Kubernetes application, Docker application, or even a VM application, we take care of that. Another primary role of Cloudlet Resource Manager is metrics. Right, metrics, hardware resource inventory of operator infrastructure, so that all that information can be used for billing, right, or optimal placement of developers' application, right, or even just for a performance metrics tool, right, for developers to use, or even operators to look at how their cloud is being utilized, right. So I forgot to mention, so operators are suppliers to us. So they are basically suppliers to edge computing. So now on the left side, we have devices like drones, AR glasses, cars, smartphones, and smart speakers, right? Who are our consumers of edge computing, or they're our customers, right? And all these application developers are different, right? It's developers and operators, they are different types of people. What that means is it's really hard for developers to work with individual operators. So we need to provide a seamless experience for developers to leverage mobile edge computing. So what we do is we have SDKs to do that. So what that allows is it's operator agnostic. It's a single set of APIs across different languages where developers are accustomed to. So for example, we have a Java SDK, we have C++ SDK, we have Unity SDK. So similar to what Twilio does, right? I think we have a Twilio SDK. So now I basically talked about consumer edge, who are our developer applications. We have the suppliers of edge, who are the operators. We basically need a matchmaker, right? So that's what distributed matching engine does. It's simply a matchmaker that looks at the requirements from developers and does its job to match the right operator infrastructure. So distributed matching engine and cloud resource manager I mentioned, it runs on every cloud infrastructure. So if you work with across different operators worldwide, you can think of this piece of software runs thousands or 10,000s on stuff, right? So what we need is a controller that configures and manages the state, right? That's what the controller does, and it's also the southbound and northbound API. So I mentioned that developers are consumers of edge. We're trying to build a developer ecosystem for them to leverage edge computing. As a result, we're doing a lot of community work, right? So we're part of Linux Foundation, TED, Muralt, a bunch of other community work that we're trying to build up a developer ecosystem. So some of the market traction that we just announced last week, so we were able to sign 13 operators across Europe, North America, and Asia, and also have onboarded 30 marquee developers across different 6 categories that I just mentioned in this slide. How we're doing this to promote the ecosystem? We're doing early access program, right? We're currently live in Europe where we're working with early developers who want to leverage edge computing, and we're expanding that to Asia and North America. We just won a winner of a 5G Asia Award with SKT Telecom for this effort as well. Finally, last slide. This was so at NWC 2019. So we were able to demonstrate world's first mobile edge mixed reality multi-gamer experience with DT, but most importantly with Niantic and Samsung. So basically we have the entire value chain from developer to developer who is Niantic, who's famous for Pokemon Go, with Samsung who's a device maker, right? Us being a platform, and DT being a cloud provider. And we had 2,000 plus visitors, and we were also visited through the thank you.
Yeah, and I guess I'll let the panelists introduce themselves, and then John, when we get to you, we'll move on to you. Okay. All right. I guess we already know one, so we'll start with you.
Hi everyone, my name is Faraz Hoodbhoy. I work for AT&T. I run what's called the outreach team of AT&T, which is part of the AT&T Foundry. Foundry is AT&T's innovation center. We're a team of about 100 people, mostly engineers, always focused on building projects. So generally the way that we operate is 36 on 8 has a group of concepts. Most of the time working with outside developers, sometimes working with big companies, sometimes just working on our own. We're always trying to find a discrete solution to a discrete problem where the multipliers start to move the needle for AT&T. Now, you've probably heard of AT&T, we're a reasonably big company. Moving the needle takes a lot of effort, which means that the impact of everything we do has to have at least $100 million impact in a 1-year time frame, or else we don't even start on it. It sounds ridiculous, but it's kind of the nature of the beast. My particular focus is on acting as the official front door for new technology across all the different business units of AT&T. So I meet with about 500 startups a year. When I say startup, I generally mean late stage, so generally Series B onwards. Evaluate them from a technology and business fit perspective, and then try to land them inside of AT&T, either in the foundry or directly with the business Last year, we saw about 500 startups. We landed about 107 of them into commercial contracts worth about $1.2 billion. So we've gotten pretty good at being able to tie technology supply to innovation demand on the inside. And it's something that I have a lot of fun doing. My background's out as an entrepreneur. I actually used to be in the audience over here, and Mario's had me up half a dozen times or more out here. But I was an entrepreneur, founder, CEO of a company in the mobile social networking space. Started my company in 2005, sold in 2011, took a year off, started to teach. I've been teaching entrepreneurship at UC Berkeley for the last 8 years. Ended up at AT&T because they told me I applied. I did not. My wife applied for me, and that's how I got here.
All right. My name is Alioto. I'm the Chief Evangelist for VidLabs Samsung. I'm responsible for our developer outreach for the Bixby platform. So, who has a Samsung device? In their home, in their pocket right now? Who's got Bixby on it? Okay, just a few. So I work on Bixby. At VidLabs, we build Bixby and we improve Bixby and we reach out to developers to help them create success on the Bixby platform. Bixby is the conversational assistant that runs across a lot of different Samsung devices. So if you have a Samsung phone or a Samsung TV or a Samsung device, you might have Bixby on it. So I work on that, working with developers to make sure that they understand how to build the platform. It's a little bit different. They'll get a chance to talk about that. But my background is a machine learning engineer. For 9 years, I ran the technical evangelism mission for Microsoft here in Northern California in the U.S. I had a startup that was based on machine learning in the security space prior to that. So I've mostly done machine learning over time, and that's kind of what I do at VidLabs as well as kind of reaching out to developers.
I'm Jay Gurudevan. I'm a lead product person for Autopilot Twilio. Assuming a lot of people know about Twilio, but if people don't know about Twilio, we're a cloud communication platform, essentially virtualized telephony and offer building blocks for developers to build programmable voice, SMS, video, and all kinds of products on top of it. Similar way, we want to democratize AI, help people really build great conversational experiences with Autopilot. That's what my team focuses on. Prior to this, I was leading conversational commerce for eBay and StopHub prior to that from October.
Ricardo Garcia, founder of VOIQ. We went through Y Combinator, raised $5 million early stage. We developed voice bots for calling for businesses for sales and marketing and support use cases. We'll talk more about that. Before that, I have an MBA from NYU. I worked at the mayor's office in the administration, developing technology roadmaps for New York City. I was a president for the mayor. We won the first Latino mayor in Property Drive-In. That's what I did before moving. Within 20 years in New York City, I've been here in San Francisco for about 4 years.
One apart from MobileMonday.
Oh, awesome, guys. Well, let's get started. So, what's the difference between LTE, 5G, and from an infrastructure perspective, and also how does Edge kind of play into 5G ecosystem?
Okay. So I think of 5G. So the way I consider 5G is that 5G has or three main characteristics behind it, right? It's ultra high reliability, ultra high bandwidth, and ultra low latency. And the way that you get to high reliability and high bandwidth is by having a session that spans across multiple spectrum. Why does this matter? Because we can have a single session where some of your bytes are being transmitted over licensed spectrum, some are going over Wi-Fi, some are going over millimeter band. Lots of different bandwidths all come together for one session. That's how you get the high reliability and the high bandwidth. The low latency piece is an interesting artifact of that approach. And here's the kicker in it, that when you have a model that has these three characteristics, you cannot apply apply it and make money by applying it to today's use cases. You've got to find a different class of use cases. So the killer app for 3G was the iPhone coming in and making mobile browsing somewhat of a reality. For 4G, it was enabling video on mobile devices. For 5G, it'll of course be those, but it has to be something different. And the low latency is, it's kind of fitting that we're in the home of low latency enablement. The key behind that, or why that becomes really interesting, is because you can now harness a whole lot more compute outside of the endpoint. And that's really where I think a lot of the opportunities start to come. So I wrote what ended up becoming AT&T's first strategy doc around edge computing about 3 years ago. And the first application that we explored was remote rendering, or rendering AR/VR experiences outside of the endpoint. And the rationale for it is pretty compelling, right? If you, how many of you have actually done some code writing around AR or VR? A few. So, you know, one of the biggest things is you need to have a GPU or a graphics processor that's going to be running those workloads. Now, the problem with those workloads are that the GPU runs at around 300 watts when you're running in full gear. And the problem with that is that you drain through battery really, really fast. And the experience is still suboptimal for trying to get an experience that's really high quality, very close up to your eyes. So now you've got a problem where silicon is probably going to take about 7 to 8 years before we get to a point where the experience is compelling enough to make us really feel that these little holographic experiences are realistic or past the uncanny valley. And so the only way you get there is by harnessing together a lot more infrastructure, and that's really where the opportunity lies around 5G. So your question was, what's the difference between 4G and 5G? It really comes back to first principles around what is it that infrastructure does? If you go back to first principles, what is a computing system? It's a combination of network, storage, and compute. Network and storage, compute and storage have generally been offered on a CapEx basis, and network is always offered on an OpEx basis. The opportunity now with 5G is for network, storage, and compute to all be offered as a service, and that changes the fundamental dynamics of what an operator is by definition, and who's going to be playing in whose territory go forward. So to me, it's probably the most exciting time that I've seen in industry, and I've been around for about 25 years in this space. This is, I think, super, super interesting in terms of the opportunities that it creates now.
Awesome. And then, how does Edge, how is that going to connect up with 5G? What's that play?
Sure. So in our context, the Edge has, so it depends on what you define as the Edge, right? So for a lot of people, the Edge is the endpoint, the point where you're actually interfacing with software that's being executed on this endpoint over here. The definition of the Edge starts to get a little blurry when your latency is going to be low enough, because I can actually have the compute and the rendering done on this device instead of being on a nice CPU that's sitting over here. I can have it sitting on a compute closet that is somewhere else in this building, or somewhere that's outside of this building in something like central office, or something that's in someplace like an Amazon cloud. Now, that's when the speed of light starts to come in and create interesting hurdles or opportunities. Because if you're going to have everybody go off to AWS in the cloud here, and you're going to start offloading all your workloads over there, the networks are not going to be able to handle it. So the proposed architecture is, can you start to create what are called regional data centers? How many of you here know what a central office is? Excellent. So AT&T's approach in this is something called CORD, which is turning the central offices into regional data centers. Central offices are those places where all the copper wires for phone lines go and terminate. And so we have about 5,000 of those central offices spread across the United States that cover about 95% of the US population. Our intent is to reclaim between 10,000 and 100,000 square feet per location. Each one of those locations has fiber in and out to other central offices, fiber to cell towers, and fiber to points of presence or mega data centers. Now, if you think about a mobile network, we're talking about hundreds of millions of endpoints, hundreds of thousands of cell towers, thousands of central offices, and tens of mega data centers or points of presence. Our thesis is not to move the compute cycles all the way down to the towers, because there's just not enough physical real estate and not enough space and power to provide compute over there, but rather to convert the central offices into those regional data centers. And that's our definition of what we're calling the edge. Another definition that a lot of people are using is something called a mobile edge cloud, which is generally characterized by a high-performance piece of compute that you put on the premises. So think something like dynamic pricing for an average Safeway or grocery store that has like 1 million items in their store, and they want to do dynamic pricing. They don't want to necessarily go back to central office or try to figure out what's the best way to price it. They want it based off of what they happen to have as inventory in their own store. And so for that, they want to run a local compute workload, and for that, they can just have what's called a mobile edge cloud, where they have a series of high-power compute in a compute cabinet running on-prem. So there's a couple of different definitions that people are using right now.
Awesome. We're good on that. How is edge cloud different from traditional cloud infrastructure that we have today? So, you know, and in terms of, you know, security, privacy, scalability, speed, and cost. So edge cloud, why is it better? Is it an evolution of cloud? I don't know if you want to.
Yes, so we consider edge computing as an extension of public cloud, right? With a few qualities, few characteristics that mobile edge computing offers, right? One is because we are working with operators where and our platform is integrated into their OSS, BSS system. We know who the users are. We know where the locations. We know where the user locations are and the identity, right? So based on that, we can dynamically provision their application closer to the user, right? So it's more. So Faraz mentioned that there's thousands and 10,000s of COs and there's 300,000 of cell towers. And imagine deploying an application across those sites. It's impossible for developers to manage that. So what edge computing requires to do, it needs to have a controller or a policy-driven mechanism where, based on applications requirements such as latency, bandwidth, privacy requirement, we deploy their applications based on that requirement. So it's more of a dynamic provision, dynamic deployment rather than a static deployment. And also all these applications that run on edge is usually ephemeral applications. So you have a group of people playing on AR multiplayer gaming tonight over beer, your lunch. So once you form a group, we automatically form that group for you guys. Once the group is formed, we automatically launch the deployment application. Once they play a game, we take that application over. So it's more of a ephemeral application that I think is going to be more prevalent in edge computing. So in terms of privacy and security, we've been working with a lot of operators right now, and they have a very strict constraint on privacy and security agreement. So this is like 100-page documentation, and even and believe it or not, half of the employee of operators are usually lawyers, right? So they really care about user data. They care about how their network is deployed, right? So that none of the data gets leaked out from their operator. So privacy and security is a main concern. It's one of the primary focus of edge computing or while working with operators.
Can you guys hear me?
Quick comment on that?
Can you guys hear back there? You guys hear okay back? They're good?
Yeah, it's outside of my realm, but I don't think edge is going to work like we think it's going to work. I don't think our concept of software development or scalability is adequate to address what is going to come. I mean, I'm in a room here of fellow nerds, so I think this analogy might land. Imagine Coruscant from Star Wars with drones everywhere and cars everywhere and flying things everywhere. And they are all needing to communicate and have a control plane that operates them in a way that they don't all crash or they don't all, right? We're going to have pods of cars that have mesh networks between each other, speaking to one another over very high bandwidth, very low latency connections. And you have to be able to do machine learning on that edge. You're not going to have time to be able to go back to the cloud and retrain a model and push it back out to these things. They're moving too fast. There's too many of them, right? So our notions of the way software looks and our notions of the way scalability looks, our current technology does not adequately describe that, and I think that's the kind of concept that edge computing is starting to think about. Imagine the power of all those Raspberry Pis out there, all those things out there in your home, in your car, all thinking together and communicating together as small pods with a control plane working with those pods. What's going to happen, right? In my mind, 5, 10, 15, 20 years from now, that's what it's going to look like. And as architects and engineers and developers, we're going to have to think of all new ways to do things to support that kind of scalability.
I'm just adding, totally for answering the question of where the hockey puck is headed, absolutely. I think everyone should be excited about that completely, new realm that we've now dealt with. But I'll answer the question, grounding it on where are things going to start now, right? So, Twilio, I deal with conversational AI, but we have a programmable wireless offering. And one of the, as for me learning this space too, one of the best examples that the team actually talks about is this customer that actually manages waste. And what they've done is this very simple but very profoundly impactful solution where a lot of these trash cans and large waste spaces essentially have this simple device, right? Super low energy device that's connected to it's an edge device essentially that's just pinging and figuring out whether the trash can is full or empty, right? Very simple application. Then what it does is connects to the cloud application for the truck driver to optimize the most useful route to basically then pick what they do. And the fascinating outcome of that is they've reduced energy consumption because these are diesel trucks and essentially one that the worst, essentially your force functioning is their current route. Huge energy savings, obviously great for climate and all kinds of stuff. So I think there's really definitely amazing things to come that we don't know about, but they're definitely great fundamental examples.
So what you're describing as an IoT use case, honestly doesn't need 5G per se. You can get away with regular cellular connectivity on 3G or 2G and still get the same benefits. So yes, those are the opportunities that are going to be here and now, but they're not really reflective of 5G. Where you said it is a real computer science problem, and the opportunity is really in understanding distributed compute in a way that we haven't understood yet. Otherwise, if you take today's use cases and put them on tomorrow's infrastructure, the cost of putting that infrastructure is not worth it. You are not going to create an economic model where anybody can afford to use that stuff to do what you're trying to do today. You've got to enable something that has never been done before. This is classic innovator's dilemma stuff, 101, for the kind of things that need to be built on 5G in order to take advantage.
So basically, tomorrow's technology, it's like sledgehammer or something.
It's too expensive. The first thing everybody thinks about 5G is CDNs. Honestly, putting on 5G and CDNs, you're putting out $12 billion worth of infrastructure to do something that is already done today, and it's not going to be cheaper. It just can't, right? The economics don't work.
So the challenge is up to the developer.
Yeah, and that's where the real opportunity is. And I'll tell you more stuff is later into it. There's super exciting opportunities for it, because here's the thing about 5G. You don't have to operate in licensed spectrum to create a 5G network. There's a whole lot of interesting things that just are loaded in that sentence. Right. Well, you can do it with remember, it's a combination of multiple spectrum, so you can do it in CBRS, you can do it in millimeter band, you can do it in Wi-Fi. None of those are licensed. You can do it in Bluetooth as well. None of those are licensed. Now have them all together, you need some way to be able to, and that's really what we're doing, is using licensed spectrum as a control plane. We talked about a control plane, and then for us that control plane is coming over licensed spectrum, and the data plane is across all the other spectrum that we talked about. That's where things start to get a little more interesting, and that's our framework of being able to make it work.
So what's the difference between what Amazon, Google, Microsoft work in traditional cloud, and how is that going to how are they basically adapting to edge? What's that play? Is it an evolution? So, hey, I'm AWS, and am I going to also have to do edge, do edge computing as an offering? Is that where the industry's headed? Is that how this is going to play out?
So I can't legally talk to what other folks are doing, but a lot of the stuff that's
But if I was hypothetically, if I were a cloud player today, is that an offering that I'm looking towards, or am I partnering up with other people?
So the smart ones are going to do it because there's an economic opportunity, or they're not going to do it. For us, we have the major assets of infrastructure. A lot of it is tied to real estate. So one of the neat things I learned when I joined AT&T is that AT&T has more real estate than the federal government. It also provides more healthcare than the federal government. So with these 5,000 central offices that we have a massive amount of real estate that is physically close to where 95% of the U.S. population is. That's kind of our asset basis in there. But what we don't know how to do is talk to developers in a way that's meaningful. So we started partnering with Microsoft. That's a public thing that I can talk about. We did a big deal with them. We announced it about a month ago, close to about $2 billion, where we're working closely with Azure and placing Azure Pop inside of those central offices. So if you're an Azure developer, you get this advantage of having data centers where your workloads can be executed closer to where your users might be. So if you use Azure Edge, that's where some of those nodes are going to be inside of our central office. We did a similar announcement with IBM. I would imagine everybody's going to do this, but ultimately there's got to be a good reason to do it. And that's where the developers are going to come in, finding those use cases that are actually able to take advantage of this infrastructure. Because right now we're just building the infrastructure and hoping to God that somebody comes. Until the people here figure out what those use cases are, it ain't worth doing.
Interesting. Yeah, so I look back. What are the products that we use today heavily that rely on LTE? On 3G, streaming Netflix, that was just painful and costly. But on LTE, how many people stream Netflix or some other thing on their mobile phone? Right? Almost on a daily basis, right? Yeah, so it's like, stuff like that. And it's interesting. Chen Sharma is a consultant in telecom. And he has a nice slide we had him here last year. We did the AI topic. And he shows like, oh, hey, look at LTE adoption and completely maps to Netflix growth. He looks at Uber's growth, the smartphone adoption. He starts to look at all these interesting technologies and how they started to enable these other services that we're using today that maybe 6 years ago never thought of.
Yeah, the filter they will come is not a good mantra anymore. You actually got to know why people are going to use this stuff before you start building stuff.
Let's talk about voice AI and smart speakers for our folks here. So what are the current challenges to voice AI and smart speakers in regards to networks and cloud computing? Do we have those technical challenges right now? And how is that going to improve our situation for at least on the consumer side? What's our experience with it? How is that going to change?
So kind of building up on that, before we get to 5G, one of the biggest bottlenecks obviously has been that's come with the low bandwidth and latency and reliability issues is the lack of the ability to create instant feedback and extremely good response time, right? The way we actually look at this from a conversational AI connecting it to portable wireless and kind of 5G advancement is, can we reach a point where the response rate for, especially in a conversational device, can match the human cognitive response time, basically, right? We don't really think about this way. If I say, an awkward day of wait, obviously it's very awkward, it doesn't feel like a conversation that I'm having right now. But you expect me to say certain things and speak at a certain rate, and you understand, catch that, and there's a conversation flow that's going on. That is not happening right now with most devices that we have. So the consequence of that is kind of having a single turn, kind of quick interactions and so on, which in a way I would argue is being a bottleneck.
And what's happening? Break it down. So I talk, I speak, hey Alexa, what time is it?
Right.
and it's like,
Yeah,
There's some delay, right? So
Right.
what's happening there until I get a response? What's that call flow?
So it depends on what is built out there, right? But essentially, obviously from the device, you're many times reaching the component endpoint, and then if there are apps and developers, at least Weather itself is a native application built by Amazon right there. But let's say you have another third-party application, then you're essentially Alexa's handing you off to another developer or whatever application that they have, and then there's computing that's done on their end. Maybe they'll ping more services. Essentially, all that needs to come back. So that in itself, essentially, what I'm getting to is the experience doesn't feel as natural in conversation, right? Whereas I would say mobile or web world, that's something you're learning to go use with. So I would say that's part of the experience that's kind of you're trained to expect certain delays and stuff. Whereas when it comes to conversation, psychologically, we're all built to have a certain pace and kind of back and forth when it comes to conversation, when it comes to psychology. So when that is out of pace or out of the right rhythm, it just doesn't feel right. And essentially you're not able to then continue to have that great conversation. So I would argue the things that will change. One is developers will be able to harness a lot more, I would encourage you to really get great at conversational psychology itself and really understand what are the tenets of conversation. That's very unique to building something as a website or an app, whereas a conversation application is very different. So a lot of new things to learn there. That's number one thing. So with much better bandwidth,
Do you have psychologists on your team?
we do actually, a professor. And that's the first thing I actually encourage. Even prior to Twilio at eBay, that's one of the first things we invested in. We invested in a team of conversational designers who came from a writing background, completely different non-tech background, which is just great in building. What does a really good dialogue look like? And a lot of these aspects that are not part of building an application or something like that. So that's number one. The second part, I heard for you is the context. Not everything has to be a conversation too. So you walk up to a store, retail experience, and if you say, I want to buy a coat, you're not having to kind of break that down and say, I want to buy a blah, blah, blah coat of this size, of this stuff, and whatnot. There's a lot of context that is relayed on real time. So with IoT, 5G, I think there's a lot more context that will also start getting relayed in these experiences that you don't have to explicitly state every single time. So I think the outbursts of a lot of these edge devices will take care of a lot of that stuff. You'll be carrying a lot of data with good privacy and all this stuff, but essentially that brings the context with you. And the third piece I'd argue is ubiquity itself. Even today in a commerce experience, you're not necessarily kind of going in and buying something right away. Especially e-commerce online, you're not necessarily going and buying something right away. It's a multi-step, multi-turn, multi-session experience that spans over a large amount of time where you make reviews, get input from other people, and so on. And that's essentially what I'd argue players like Bixby and Alexa and Google are doing. They want to start putting more and more devices on you, endpoints on you, that can help enable that ubiquity so that you can start an experience somewhere. I like somebody's shoes, I can take a picture, send it off to the assistant, and then it'll go about its way to then understand several things. The size I like, the brand I like, maybe when I'm in a certain place, that store ends up having that inventory. That kind of ubiquitous experience has not really been unlocked. And I think those are really kind of the untapped potential for what we think of as an intelligent, always on kind of an assistant experience that can be unlocked.
The interesting thing about the way Bixby works is to your point, is when the ASR, the automated speech recognition on the phone occurs, all that information gets sent to the cloud. Bixby lives in the cloud itself, and every single time you speak to that assistant, it goes back to an AI, to a machine learning algorithm essentially, and figures out what you were trying to tell it. So Bixby works a little bit different. It is a large AI that lives in the cloud. You teach it, when you build a capsule or apps for Bixby, what you do is you teach Bixby to do something, and the entire platform gets smarter. So Bixby very quickly figures out, okay, this is what you're trying to get. This is what the user's intent is. I can use these capsules, this functionality to get it there. Get me a ticket to the Super Bowl, the month after my sister's wedding, right? It's going to have to go out and figure out all kinds of, who's your sister, when is her wedding, where is it located, What is the date of that? Where is the biggest airport near that? Where do you live? How do I get you a plane ticket from here to there? An assistant who worked for you, a human, would be able to do all these things without asking you, which one of these is your system? Which airport would you like to fly on? And even a less ridiculous example, it's like, hey Bixby, I'm flying to LA next week. Can you book a hotel? Are you going for business or pleasure? I'm going for business. Okay, John, the Westin you usually stay at near LAX is available from this date to this date. Is that what you want? Yes. Boom, it's done. Right? So, in combination with that notion of edge computing, just imagine if you could have Azure Data Center. This is what Satya is thinking about. By the way, I'm no longer with Microsoft. I am a shareholder. Full disclosure. This is the way Satya is thinking about this problem. Imagine you had an Azure Data Center in your pocket, right? Okay, it seems ridiculous, but if 15 or 20 years ago I said you're gonna have a quad-core computer with 64 gigs of RAM, you'd be like, no, you know I'm not, in your pocket. Someday you're gonna have an Azure Data Center in here. Someday you're gonna have an AI assistant that has enough power and capability that it all lives right here. And there's not going to be this, I go back to the cloud and take advantage of all these servers and all this data in AWS. It's going to be right here. It's going to be in some sort of form factor that's right in your pocket or right in your home. And then all those kind of, hey, you know, Amazon's listening to my conversation type of things go away because it lives in your pocket, right? So a lot of interesting things are going to happen as compute power and networking power and artificial intelligence get into the edge device.
Yes, I can give you an example. We're an example of the application layer leveraging the evolution of AI in 3 different categories over the past 60 years, where the text-to-speech, speech-to-text, natural language understanding, the only reason we're able to get to this point is those 3 technologies, AI enabled it to do it, and the only computational power that's able to do it right now is in the cloud. Eventually it will get to the phones. So we have to wait for that. In the meantime, we have companies like mine that there are several players. This is like day one for AI voice, especially for the enterprise and for businesses. So there's several players doing their best at each of one of those, natural language understanding, text-to-speech, speech-to-text, right? And constantly, one of them is better than the other, and we constantly are stitching the best possible service from when a voice bot in our platform, a voice bot has a natural conversation with a human over the phone for businesses. And our biggest challenge is latency. In that tiny little gap between, hi, is this John? Yes. Great, John. That millisecond is our biggest problem. And the solution comes in multiple different ways. You have the AI on premise. So if you bring the understanding all this stuff closer to your computational location, that solves it. Or if you increase the speed at which you get that information back and forth. So we're definitely affected by that. It's moving really fast. Twilio is working on it. SignalWire, a bunch of different telecommunication companies at the developer level are working on it. One of my favorite, it's interesting because this is sort of still day one in AI voice. One of my favorite stories is that when Siri came out, they started Adam and amongst the other founders, Doug and Adam. They started Siri in 2008, they sold it in 2010, they got acquired by Apple. And what's really cool is when they launched the product, they had, it was magical because it was end-to-end voice, but it wasn't initially built that way. It was, you ask the question with voice, and it will give you the result on your phone. They said, let's hold up the release, let's make it magical, and they just plugged into Nuance, which has been doing 20 years text-to-speech. And so they were stitching services even back then, and that's what's happening. The more advanced technology you can, one single company cannot tackle it. There's 6 giants, and you have silos of everyone tackling each specific space, and then you need to stitch it, and eventually sort of like a huge cycle. Cloud, on-premise, et cetera, and consolidation. So it's really interesting.
So where that points to is basically service chaining. This idea of having applications built on top of multiple functions coming together. Everybody's heard of what microservices are. This is where the rubber starts to hit the road. It's in the chaining of those microservices that start getting the really good applications coming together. The infrastructure to tie those microservices together with the right latency is where the key is for the success or failure of the kinds of applications you're describing. So the Alexa pod that's in your house is not where the compute is happening. It's happening outside of it, and the chaining that's happening is the handoff from all these different points. The infrastructure, if it doesn't recognize that these microservices can be executed at different places and come back to you with the most, with a service level that is not on the traditional metrics of networks around how much time, but really around what is the end-to-end application latency. That requires a whole bunch of compute changes. We don't think in terms of service chaining when we're building out network SLAs today. That fundamentally changes what it is that you're asking of the infrastructure. And that's where it starts to get really exciting. So you'll see tons of companies now who are just focused on, hey, let me tell you the time for your microservice execution, and then come back to you with where should we start placing all these pieces. One of my favorite examples was from a company called Rolf, where they took a Salesforce application running in India, where every day they had people in India who were running Salesforce, 2,000 people, call center reps, who were looking up Salesforce requests, and each of them was losing about 2 to 7 minutes a day. And that was because the login function was done in Singapore, was done in the UK, and these guys were all in India. And what they found was that they took the login function, the microservice login, and moved it from the UK to Singapore. All of a sudden, they had 2,000 people who gained about 8 minutes a day in terms of their productivity for a given day. Very simple, stupid example, but it is incredibly powerful in terms of the impact to what better infrastructure can do and better knowledge of how to build your apps.
Great discussion, guys. And I think we touched on a couple of other items that we had slated. But let's come back to 5G and Edge. So now let's merge the two technologies together. So now it's the year 3000 and 5G is deployed. We have Edge.
God, it's going to be faster.
In the year 2000. But coming soon, right? Coming soon, 5G Edge cloud service deployments. In the near term, how could these two technologies improve what John and Jay are doing, and how does it improve Ricardo's life and his customers?
I swore I was just answering that one earlier. So I won't try to do the same answer for that.
Right. So it's just going to get faster, right? Things get faster, and
Your visibility as a developer, the tools that the network and the infrastructure provide need to give you a whole lot more than what they're doing today. And it won't just be the network providers doing this, it'll be the development platforms that you're building off of. They'll have to give you that many more identifiers, that many more metrics around what service is being executed when and where, and then how do you get sort of an SLA around the chain set of services, which is the app that you've created. And so there's a big infrastructure taking hold right now to think in those terms. We don't think in those terms as network providers, as storage providers, as compute providers, but as next generation edge compute, or really next generation application infrastructure providers that we have to.
For the assistant, it's all about context. So I'll give you an example that works today. If I'm standing across the street from Cloudflare and I ask it, hey Bixby, where's Cloudflare? The NLU is going to upscore things that are near me. So it's going to, if I'm way far away from Cloudflare, it might think I've said something completely different, Cloudflower or something like that. But because I'm standing here, it's going to upscore that. It's going to take the context of what it understands about where I am, my geolocation, and give me better results. Think about that in the context of a personal assistant that actually knows you. That is you. I'm total we're building the end of the world guy, so if you want to come up and talk to me about it, AI is going to destroy the world after, I'd love to talk to you about it. But and if you're into kind of transhumanism, just imagine where you have this kind of assistant that knows you and knows what you do and knows your context always and can answer the questions that
It's
you
the
might
it's the virtual you, right?
It's the virtual you. It's an extension of your mind out into technology. I mean, you said the year 3000, so I'm going there. It's going to extend your consciousness out into the technology, and the AI is going to work together with you to figure out what it is you are asking it, or you need, or even anticipating your needs before you even ask it. Right?
The bandwidth needs to be resolved, right?
Yes.
That's supposed to swap it, right?
Exactly
It
right.
makes sense to, whether it be neural link or whatever. So, yeah.
And so just to add on top of that, John, is that so John mentioned about location aware, identity aware. This is what the 5G operator can
Closer,
offer.
put it closer. So I can hear you. Put it closer. I think it's not. It's just you that close.
Yeah, so this is what operators can offer to verify the user. Remember, all these devices can be spoofed, right? GPS can be spoofed, right? So by integrating your platform into operator network, your identity and your location can be verified by the operator.
Ricardo, how's this gonna, so 5G, now we have edge computing. Is it just the latency that's being resolved? Is that just their biggest problem?
No, with more processing power, the smarter it's going to get. And like I said, I think 5G could be a solution. It gets harder to get some information from the brain to where you need it. That solves it. But also, miniaturizing being able to process what is currently only possible to process in the cloud in your pocket, or whatever, something small, regular location or premise, and suddenly you solve that problem. So we're not far from solving that problem. I would say right now, out of the box, you can buy a synthetic voice that sounds almost, definitely almost human, perfectly human. You can train it to sound perfectly human with a specific, let's say you have a very narrow, which we do, the type of calls that we do are very narrow. The voice bot asks you, hey, thank you for, hi John, thank you for registering on the free quote for your car insurance. I just have an additional question, how many miles does your car have, right? So this is a voice bot asking you a very narrow question. So, in that sense, we don't need a lot of, it's right around. But if you want to have, like, calling, pick one, different Verizon, for customer support, right? And you want the AI voice to be able to understand what you said, no matter what you said. Like, hi, how can I help you? Well, my grandma's in town, she broke her cat, she spilled the water, and now my internet. We need way more processing power because that's way too wide for the NLU to kind of understand. So for narrow stuff, latency is the easy problem to fix. For NLU, that's a much harder problem, and that's, we might need a decade or two in order to really get there. It's not around the corner, but it's super expensive, and I do it really so.
Sure.
Yeah, so just to give you some number context, so what Ricardo is talking about is MTP, so it's 25 milliseconds. So when the latency is less than 25 milliseconds, humans cannot feel that, right? It's when the latency is more than 25 milliseconds, that's when you have a bad experience. So just to give you a context of latency numbers for LTE is around 30 milliseconds, right? Is that the right number?
No,
25.
that's fast.
Right.
I mean, typically, I've seen numbers quoting between 40 and 150 milliseconds.
Right, so while I was testing at DT, I was seeing around 35. It also depends on the time and the day, right? So what the promise of 5G brings is right now the 5G deployment is called NSX, non-standard deployment, or non-standalone deployment, which means is that they're not actually ripping off the LTE network, they're basically replacing the NR, the new radio. And what that allows you to do is it shaves about 10 milliseconds of latency there. So with the current 5G deployment, your RTT becomes 15 milliseconds to 10 milliseconds, right? Give or take. Yeah. So now what Ricardo is asking becomes below 25 milliseconds, right? And when Ricardo's application runs on edge on top of 5G, there's your solution.
There's also, the notion of if the application is visual, that 25 millisecond or latency budget is for the full round trip for the entire rendered scene. But if that rendered scene is dependent on what did the other guy do as well, and kind of combine that in there, now you add that to the training piece in there, so it becomes a lot harder. So it really depends on the experience that you're doing. Also, from an audio standpoint, I really can't tell as much of the difference between 80 milliseconds and even 30 or 40 milliseconds from an audio perspective. When I'm on the web browsing, we're typically seeing about a half second for a page to load, up to a couple of seconds depending on what's happening. But when it's a real-time game and visual elements need to come in sequence, your budgets are a lot lower. And so if you look at cloud rendering services like GeForce Now, they do a spectacularly good job. But the way that they do that is by not messing around with trying to get latency budgets, but over-provision the compute to basically, if you can assume that there's going to be 10 different outcomes, they'll render all 10 different outcomes and send it down. So let me give you an anecdote for that. My son uses GeForce Now. My bandwidth at home, I have a terabyte limit. Right now I'm doing about 1.8 to 2 terabytes a month ever since he switched over to GeForce Now. Which means that they basically shove a whole lot more information down, which offsets the need for better latency. So there are methods to get around the problems, but it does come at a cost. And when you look at it, the flip side, the cost of bandwidth is a couple of $100 now, versus the cost of the actual gaming service, maybe $20. So the infrastructure is more expensive than the gaming opportunity right now. So there's an imbalance in the way the system is built.
One question for Ricardo. So when we met, you were looking for business model, right? People were calling, you had humans, how has AI really, transformed your business?
Yeah, for sure. So just to give you a little bit of background, so we set out to build a platform that would listen to humans, professional humans, sales and marketing calls, because we couldn't get automating the voice. Kind of, we were hoping that there would be humans to drive the cars. So we started very much in that sort of model, but we automated everything else. So we listened to the calls, we're transcribing, annotating, tagging it, optimizing it, telling the agents what to do. And the last piece of unpredictability was the human. And we wanted to get predictable revenue. How do we make sure that when a company says we're going to do this, we're going to call this many people, whatever, they're going to get exactly this amount of money in terms of returns. In order to do it, we need to replace that unpredictability. So we were testing voice bots for a while, and not until about a year ago, we decided the technology was finally there to really get serious enough to start building business applications, business level applications for AI voice. And that's actually, I'm going to be giving a keynote on Wednesday at a conference specifically on this, like the AI innovation, specifically for businesses. We've seen AI voice in the consumer, Alexa, the assistant, it's incredible. And now it's, all right, we got to the point where we can actually build serious, we have an oracle, and you have everyone kind of jumping aboard that. But it's like day one. So for us, it was dramatic. We switched, we were able to switch from humans to voice. We had our the moment that Uber has been waiting forever, we had it earlier than expected. We thought it was going to take a couple more years, and we were hoping to wrap that in, and we just happened to jump much earlier than. And like I said, we do very narrow natural language understanding. So if you are doing something that requires a long conversation, open-ended conversations, it's very difficult. But anybody who's done sales and marketing, lead generation type of calls, these are 1-minute calls that you're directly in conversation and you're asking for very specific questions. So that's where we can actually works for us.
I was just going to add that we're going to see acceleration of that kind of application on the business side of things because, again, on the eBay side of things, we're working on consumer side of things, but the business side of things, we're seeing a lot of Twilio because there's this interesting trend that usually conflicts each other, I would say. So customers prefer more and more self-service. They do not want to wait for, the wait music to wait to talk to someone, right? That's why you're going for the bad example, per se, right? For that's on one side. So most service, 70-80%, very high number of people basically want self-service, especially the airport. And on the other side, people also want very high-touch, high-quality experience too, right? So these both kind of don't really work because what you have right now then is like press 1 for for this and that, this DTMF IPR stuff was super annoying and not very high tech. So, but now, in these narrow use cases, and with enough, I think, in advances now with LU, text-to-speech, and steps and stuff, we're able to basically get to a point to solve that problem where people can reach self-service solution for the most part, the majority of their problems very quickly with a pretty high quality experience. So that, we see an acceleration.
Yeah, exactly. I mean, this technology allows you to be extremely relevant. When you have a conversation with somebody, they're calling you because you just did something to trigger it. It could be automatically triggers, or, you know, like the example, you fill out a free quote for car insurance on the website, somebody calls you 5 minutes, and they know your name, they know your car, they just need a couple of additional questions. It's extremely relevant, so you actually want to take that call because you literally were looking for car insurance in that second. So that's the type of, the high relevancy comes from the fact that it's bringing highly customizable, you know who you are, right? So it makes it, it's not what people normally, it's normal for people to say, I don't want to talk to anyone, I just want to go my own. Of course, because the experience is horrendous. Why would you ever want to go put yourself through menus? But when it works, people do not mind relevance. They will, right? Because your doctor reminding you to make sure you're there in an hour, it's confirming that you schedule a demo with somebody and it's confirming that you want to make sure you showed up. If you didn't show up, it's calling you to remind you to reschedule, right? These are things that you decided that you want to be part of the process, and now the voice bot is helping you make sure that you get through that process.
I think we're going to open it up to audience questions now. Before you guys leave, John has 2 tickets to give away for the Samsung Developer Conference. And so he's going to ask questions to the audience and folks that apply and answer right. Free pass.
Yeah, so the Samsung Developer Conference here in San Jose at the end of October, 29th and 30th. We're going to talk about all kinds of things in development in Samsung, but my group's going to talk about developing Bixby. So, yeah, cool. Free pass.
Question?
So I guess my question is, you've got Echo, you've got Google Now, whatever, and Siri used to be somewhat relevant, and Bixby, but they're less useful than they used to be. I mean, Alexa is actually useful when you do things with it because I think it knows enough about your environment. What are the things that these voice apps need to be more relevant in, you've got devices in your home, you've got devices on your phone. What are the things that they need that they don't have right now to be more relevant?
So I could start with a short story that you mentioned Siri initially, and I think kind of Siri gets a lot of criticism because when they got acquired, it was the latest technology, and actually it was sort of one of the favorite projects by Steve Jobs. And when they launched, Steve Jobs passed away a week after. And so suddenly no one really cares much as voice within Apple. And that's the reason why, that's one of the main reasons why. Eventually the founders left after 2 or 3 years, the founders, they left and founded a little bit bigger what he's working on. So that's a little explanation as to what happened to Siri. That's the first part. The second part, I don't know if you guys want to tackle it.
Yeah, absolutely. I mean, it needs, to me, they need to understand who you are. They need personalization, right? It's annoying to have to explain to your assistant again and again and again who you are, where you want to go, what selections you want to make, what are the things that you normally do. If you think about it, if it was a human assistant and you had to continually explain the same thing over and over again, it would be very odd to you. It would be like, what's going on? So, if this assistant doesn't know who you are and what you generally choose and where you generally go, it just is annoying. Like, I'm the guy who's sitting there pounding 0 the moment I hear a bot. Because I know, as deftly as this developer has built that bot, it's just moving me through a conversation tree to get to the right line in a fact that it can read me. It doesn't know who I am, what I want, or how to help me. So I'm like 0 representative, 0 representative. I want to talk to someone who can address address my specific needs. And you know, I sit right next to Adam every day. Adam Tyler, who, you know, kind of built Siri, founded Siri. And, you know, one of the things he likes to say is, we're not trying to build the world's best assistant. We're trying to build a platform to allow the world to build the best possible assistant. So when you build a capsule for Bixby, you're making the platform smarter, and you're making the platform more capable. And as this platform becomes more capable and understands who you are as an individual and as a user, to me that makes it 10 times more valuable.
So I'll speak from a perspective of not just really, but prior to that as a developer for an eBay team, startup teams that worked on the Messenger platform, Google Assistant, and with Bixby and others too. So there's definitely a product market fit problem that has plagued this world for a while, right? But our team, we had a quote in our offices, and I repeat that. We grossly overestimate the impact of these things in the short term and underestimate the impact of these things in the long term. So to really frame yourself, this is like 2008, you're an early app developer, this is like early web developer. There was that phase you go through when a new platform comes out, and people are just trying to figure out what is really the killer app use case, right? So think about the mobile phones right before. Email was great, sure, kind of BlackBerry to iPhone too, but prior to Angry Birds in a way, it may not be the true milestone, but I would say that was kind of the big milestone that figured out, oh yeah, this whole touch thing is magic here. And then things really changed, and then of course Uber and all those other applications came because two people can know where they are and so on. I do think that is definitely, Gartner Hype Cycle puts it, if you go look at it, they did a rating study of where these things are, where they're going to reach maturity, kind of a 2 to 5 year frame. So that's all kind of the background of where these things are going to go. But what these things are great at are, regarding a lot of great examples, I would say, well, there's a lot of shot that people are trying to take right now, kind of this general intelligence, not general artificial intelligence, like general assistant, which is a very hard problem to solve, right? Even I have complete IoT at home. If my light names are so close, even with Google Assistant, I say 1,000 times, it will catch the wrong lights because my baby's crying in the background or whatever, right? It's a very hard problem to solve. So, but I'm not going to make an excuse for that. What I do as a developer myself, what I've seen is something like Messenger, for example. You know, if you build a general chatbot and stuff there, it didn't really work as well. One ended up actually working great because people shop from Instagram a lot of those are images, and there was not a great way to start shopping from there. Turns out what they could do, send that image to the eBay bot on Messenger, one button, and it will always find the right item for you, right? So it's not your traditional kind of, I'm going back and forth. I'm just saying, I like those shoes, I like the surfboard or whatever. Already your account has your size, your gender, all this other stuff already mapped in. What would have taken 7, 8 steps was now suddenly much faster. Now it's become a growth angle for that business, right? And same way on Google Assistant, a lot of times you see search is a big problem. People don't think of like a lot of the queries that you ask many times are search queries. That's really what you're asking for. And of course, right now we can ask simple questions like what does a whale sound like or music. But over time, a lot of great examples of like I can buy tickets to get somewhere. It's essentially a complicated search query you're doing. And their pieces are coming together to solve it. So that's the way I would say if you want to take advantage of these changes, look at it those ways, and you will definitely see the look around the corner in terms of what's happening.
And the last piece that I would add to that is expectations. So it's really interesting why each of these big companies decided to name AT&T personalities to their assistants. Google was very, they knew exactly what they were doing. They weren't really kind of do like what Alexa does, and that's really, people, when you give a name, your personality to the assistant, people actually expect them to behave like humans, and they suddenly expect more from your assistant, right? And that's what happened here. But Google was on purpose, that they called it Google Assistant, saying, this is not a human, this is just an assistant, right? Just expectations. And I think a lot of people interacting with Siri, a lot of people interacting with Alexa, it's like, oh, this is not that smart, right? Google Assistant is like, oh, it is an assistant. So it's really expectations you take each macro.
AI is not PC us. That's for sure.
We have another question right here.
Yes, a little bit of a statement and a question. So my company, MobileMonday, we're time series database. We have lots of customers, actually paying customers, and Korea, like Samsung Heavy Industries laundry ships, and actually on the robots themselves, 500 robots in factories. So it's all kind of IoT data, like big data, massive data. And we actually work on Raspberry Pi. So that's great in like Korea, and it's actually happening in Korea and IoT, especially vibration monitoring and HMD. But like the outside world, the question is like what applications? It seems like Asia is a IoT kind of a place, but the US especially not so much. So what the question is really, what kind of applications do you think will be the actual first paying customers for HMD?
So we've got a fairly big IoT practice, and I'll tell you the coolest workload that I saw, it was the single largest workload of any company I've seen. I can't tell you their name yet. But what they do is stick a camera on top of a worker in a factory and use computer vision to figure out, has the worker done all the steps that they're supposed to do at that particular moment in the assembly line? So if there's 16 steps, did they do each of the 16 steps? How long did it take them? Well, the workload is insane. So there's a 1080p camera on top of it. You're taking that 24/7 stream, and you've got 100 of these cameras for a single location. There's some fundamental things that are broken with infrastructure. So networks were designed for time immemorial to be on an 80-20 rule basis, where 80% of the data was going to be focused on downstream data, and 20% was upstream. As we go to 5G and we get to all these industrial IoT cases where the sensors are generating all this information, sending it up somewhere, do a whole bunch of compute, and then bring it back down, the balance of which way traffic is going is switching very, very heavily. So that workload that I described is about 1 terabyte a day of uploaded data from a single location. There really isn't any bandwidth, fiber or not, that's going to do a good job being able to give you 1 terabyte or 2 terabytes a day upload, and then you take that and you go and stick it into AWS and start doing a whole bunch of compute around it. You're talking about a GPU per camera. You're talking about an insane, like hundreds of thousands of dollars infrastructure bill for just processing those feeds, and then coming back. And if you want to do it in real time, you can't. Because the amount of compute required is going to give you at least a 4 to 15-minute delay before it comes back. So that's where that idea of, can I get high enough compute and run it in a compute closet that's on-prem, so I don't actually have to take it off-prem to go do that? And can I figure out a way to be able to develop my software to be able to handle all those complex functions all on-prem, and then come back with the results? Well, the flip side of that is if you get that right, you can actually now use it not just for worker productivity, but actually quality control. And you talk to anybody in the industrial space, the biggest problem is around reducing failure rates on a parts per million basis. And companies are willing to spend billions of dollars in their assembly lines to fix that, but don't have any technologies that can do that today. This example that I gave you was one that technically is one that can work, but where infrastructure falls down. So I did not see that I did not see work like that happening outside the US, and I see a lot of stuff happening out there. I would argue that some of the most interesting applications are actually happening here. And if you look at all the manufacturing stuff that's happening around the roboticization of the workload. China's got some excellent work happening around there. But the infrastructure is still busted, and take a device from Apple or Samsung or pick your favorite one. How many robots do you think actually go into those assembly lines? It's actually still majority humans who are doing the assembly of very complex devices like that. So there's still a lot of room for improving the process.
But in that case, you do your training with your data center, and you actually do your inference at the edge or at your facility, right? And that's how people are getting around that. Right?
Well,
you're not expecting to send it all up to the data center. You're actually looking at the localized.
So the training, so yes, you have to train, but you still have to look at all the actions that the worker is doing. That's still a compute-heavy exercise.
In the closet, right? On models you've already figured out, and
oh, sure.
There are a number of companies that are.
So the training is actually not the real problem. Training you can do in about 10 hours worth of data per camera. But doing the inference has to be 24/7. And so yeah, you could split the workload out. That's a good example of a distributed compute model where the training is done maybe in the cloud and the inference on what the worker is doing is done inside the compute closet there. Yeah, totally agree with it.
Right, we got 2 more questions.
Ask the question.
Hi, Ross Mead. I came up from LA just to see you guys. We talked about a lot of really great technological solutions to these problems. I was wondering if you could talk a little bit about some non-technological solutions. So you've got problems with latency, and I'm wondering how much of character design comes into this, and I think what Ricardo alluded to, expectation setting. How does that come into play in design of Bixby or what Twilio is doing or these other assistants that are out there?
I'll talk a little bit about this. So this is one of the partners we're working with. So they're to help people develop their applications like just in terms of setting expectations, obviously, across the board, with not just with your customer, even within the company. Again, first slide I always put up was AI is not going to see us. It's not going to solve all your problems, right? So I think it's very important to kind of frame the problem, set very clear ROI, and kind of work towards that. It's very important. And there are already pretty good use cases, I think, these days now that you can start seeing that there's pretty good ROI already examples out that you can start with. You're likely going to have a good outcome versus still kind of shooting start. The kind of talk about training and stuff. A lot of times people get excited with wanting to build the application, put it out, they're going to try it out. There's really, it's important to be very disciplined with really actually investing probably the majority of time early on in actually training and making sure the experience outcome is really what you want to get to. Again, kind of going to the app world analogy, free or any of this other stuff, there are a lot of people that were just trying to, I had some of the early Microsoft phones. I remember it was literally like a star bar in the phone. That's ridiculous, right? So you're trying to really kind of force fit like a website or into an app or on mobile. People are still trying to do the same thing with conversational experiences where that's kind of what this problem is of like, oh, there's like a workflow, I'm going to put the same thing and then one by one, what's the point of this, right? So I think you want to really spend a lot of time in understanding, I mentioned conversational psychology, it's really important to kind of think about what is a good conversation, what does an outcome look like, what does a great agent experience look like. Then invest the time in getting that right, then your outcome is much likely.
Good resources for that?
There's a ton of stock after it. Yeah, there's good research and a lot of people working about it.
So there's an interesting thing, this interesting issue that we have, which is we're a SaaS platform. So most people think that what we do is that we go and build a voice platform company and we sell it to your contact center or your call center and you sell it to the CTOs. No, it's a SaaS platform. So anybody who launched like an email drip campaign, that's our customer, except that before you could only do automated email drip campaigns and you can do trigger text, and now you have a branded channel. So that same person, the sales manager, sales automation, whatever title, growth hacker, anywhere you want, they have this type of titles. This is the first time in the history of marketing where they have control over the call channel. So it's great, but at the same time, they've never been in charge of a call center. So they don't know how to write a script for a call center, right? So their experience comes from writing an email thing, and email they have 25 years of experience trying to get it right, and still it's extremely difficult to get email marketing right cadence and stuff. So now you have this open channel. Person who never had this power in their hands, and now they have to kind of learn what to, because you're actually typing all the different, the workflow as to what this voice you want to get the information to the customer. So that's an interesting issue when it's new, right? They have to learn.
If you think about the way a human is built, the entire, maybe front half of your brain is basically a visual processing unit, right? It is all about visual processing. So when I type in to Google, Weston near LAX, instantaneously I understand this is a map. I understand these little things overlaid on the map are locations. I instantly understand the blue one is me, the red one is what I want. Instantaneously, this information comes into my mind and I'm able to visually process that. if you're doing a voice-first experience with an assistant, I cannot tolerate, there are 6 hotels near LAX. The first one is 1.26 miles from where you live. I'm like, okay, I'm done with you. So you really have to think about, to your point, how your user and the human is going to interact with this assistant in not just a way, most of the assistants are getting screens now, Bixby's on mobile, Alexa's got a screen, but in a voice-first way, when you have those moments of need where you can't pull out your phone, you're in a car, you're not, you want to speak to it, right? And how that interaction, headphones, yeah, they're the heroes, how your interaction is going to be. And there's great resources out there. BixbyDevelopers.com is a good one. We've got a bunch of design documents from our designers about kind of building voice first experience.
I would add to that, if you're serious about it, every major assistant platform has put out pretty good resources. Twilio does too. You can actually email me if you want some specific stuff. We're doing our own playbook for how to design these things and whatnot. But yeah, but it's not like there's no holy grail, right? So you really, one good practice I would recommend. Contact center is a very good one. Like agents are trained through transcripts, so really kind of starting from there is a very good one for those set of use cases. For Starbucks, for example, what we ended up doing was we went to our New York Times Square location where tourists and all kinds of people come and talk to someone and say, I'm in New York for a week, I want to see a Broadway show or something. We literally, it was awkward at first, but we were just like stopping the conversation, literally trying to see how does it start and what do they play with, what works out, what do they really walk out with. And very quickly you realize even though you've been building an app inside for the longest time, it's a very different direction in which it goes. Like that's just building on that example, they would say, instead of saying I have 5 options, like my favorite show right now is Hamilton or whatever, right? So just even qualifying things that way changes the direction very quickly. So you can play into a lot of those nuances. I mean that plays into that second.
Cool, guys. We got one last question, and then guys will hang out, because John, can they give it away real quick? Okay.
Hi, this is Ben from OpenPath. So I also came from LA to just talk to you guys. So my question about the voice assistant is, I assume that when you want to have a personalized voice assistant, the first thing that your assistant needs to do is to pick up your name. So my name is Ben Chaplin, and I'm pretty sure that no one here could figure out what did I just say. And I assume that this is going to be like a hard problem. So my first question is, how well you are performing and picking up names in voice assistant concepts? And my second question is, if there are any benchmarks out there that you can actually evaluate different voice assistants on different criteria, like picking up names.
Sure. So I don't want to announce any features here, but yes, there are, that's absolutely right. It's a very important functionality. In fact, the ruling conversation of making a connection, right? Each of us, we all do each other through email, but when we met, we exchange names first. It's absolutely important. It is not a too hard problem, depending on what kind of database and stuff that you have access for. So Twilio, that's one of the things we're definitely already solving, and you will hear more about it very, very soon, actually.
Yeah, absolutely. I mean, on ASR, the speech recognition is totally critical, and you have to think about it from a culture perspective. If I have my assistant in ENUS, it's probably going to interpret my utterance in a way that is likely an ENUS response, but when I give it a name that is not typically something you would imagine as an ENUS name, it's not going to get it right. It's going to give me some ridiculous 2-word combination, right? So it's really about understanding a lot of different cultures, having a lot of different languages in your ASR, and then again, I hate to be a broken record, your assistant understanding who you are, what languages you speak, what culture you're interested in, what you are generally saying to it, and then using its intelligence to figure out, okay, I'm going to upscore this because you're likely just said something to me in French, when, even though your phone is in English, I happen to know you ask me questions in French a lot. So, it's really about understanding who you are and what culture is important to you and what you typically do. And then, of course, having all that training from native speakers of those languages and cultures as part of your platform so that your ASR does it right. And it's a very non-trivial problem, but super important.
And I think even before you get to training yes, it gets your name the right way. Strongly sales and marketing or companies that sell leads, it's probably going to be a field that they're going to have, especially if there's more companies like mine. We will want to know. Certainly, it's very important to not pronounce it, especially if it's not human. And so I would expect that to come out, especially from a regeneration type of thing. Like zoom info on this database. And the other part is QA, and that's one of the areas that companies, when they speak about what we do, they tend to focus a lot on the speech to text, text to speech, but the unsung hero here is QA. It's how all these calls are recorded and training the platform to not make the same mistake more than twice, more than once. And QA is a huge, it's I would say 85% AI and the rest human. And the human would be the one catching something like yours and feeding it into it and say, this should not happen again, and tagging. Right? So you have a lot of analytics and tagging, all these solutions that happen in the back end, so it doesn't happen again moving forward. That's kind of like the not so exciting piece of the not sexy part, but it's what makes a platform super successful.
The last month.
Yeah.
Can I add something to what you said? The name recognition, I'm an ex-nuance, so we used to face that a lot. Recognizing name, like you said, is not as much of a real data problem. It's data there. But what we were struggling on is how much capacity do you have at the edge in terms of compute and storage. When you're designing a system with 100 or 200 megabytes of memory, you can only pack so many for your language model. And you're not going to be able to recognize a German name if you are putting a US. So that's a bigger problem than actually ASR system recognizing. Those models can do pretty well. It's just that you cannot put big data points in the edge.
And you solve for that with trying to be clever, right? Like I said, anytime there's a constraint, we talk about context a lot. I think that's an important topic to think about. Like, do you do your homework before that interaction, right? So the way we're kind of solving that is the ending process and stuff, because you have named either already through the interaction, before the interaction, or through other forms that can help bump up the probability that
And until it gets smarter, they're always shortcuts, right? Calling you J instead of whatever it's pronounced. So it's full of shortcuts to try to wait until 15 years until actually it's smart.
Cool. Thanks, everybody.